In this lesson, we will cover loading electrical equipment families into a project, selecting the appropriate electrical equipment type to place, and placing electrical equipment at the correct location. In this model, there's an electrical room on the ground floor level, and there's also an equipment pad placed outside of the electrical room. We'll place a couple panel boards inside the electrical room, and then we'll place a transformer on the pad located outside. You can load electrical equipment families into a project before using the electrical equipment tool. To do this, switch to the Insert ribbon, and in the Load from Library panel, click Load Family. Or you can switch to the Systems ribbon, and in the Electrical panel, click Electrical Equipment. This activates the Electrical Equipment tool, and you can see that the Load Family tool is also available on the contextual ribbon. When you click Load Family, the Load Family dialog opens. For this example, we'll use the default family library. Open Electrical, MEP, Electric Power, Distribution. In this folder, you can see several different types of families. We'll load in a couple panel boards. You can see that some of them are indicated as surface, meaning they're surface mounted, and the ones that are not are recessed. You can use Control to select multiple families, and you can also use Shift to select multiple families at once, and then load them all into the project. For this example, we'll select the 208 volt MCB surface panel along with the 480 volt MCB surface panel. With those two selected, click Open. When you do, those families are loaded into the project, and when you expand the type selector, you can see those two families that we just loaded along with any other families that have already been loaded into the project. For this example, I'll select one of the 208 volt panels that we just loaded. With one of those family types selected, you can see that when I move my cursor into the drawing area, there is a cannot place symbol. And the reason is because this is a face-based family. You can see this, or you can tell that because there is a placement panel in the contextual ribbon. For a panel board, you're likely going to use Place on Vertical Face, but depending on what type of component it is, you could also do Place on Face if it was going to be on the floor, or even Place on Work Plane, and then you could select a level or a reference plane to place it on. For this example, I'll leave Place on Vertical Face selected, and then I'll move the cursor into the electrical room, and when I move my cursor over a wall, you can then see the panel board. And I'll simply click to place one of the panel boards on the back wall of the electrical room. Next, I will select one of the 480 volt MCB panels, and I'll place one on next to the first one that we placed. And then I'll click Modify to end the command. Now, when I select one of the panel boards, you can see that there are several parameters in the Properties palette. You can see that there is a Scheduled Level parameter, and then there's an Elevation From level. Now this will control the height of the panel board. You can also see a Host parameter, and this will show you that it's a linked architectural model, and it'll show you the actual link. And this parameter will move the panel board either away from the wall or closer to the wall. So for example, if I input 1 foot, it will move it away from the wall 1 foot. And I'll change it back to 0, and it'll be on the wall again. So elevation from level will move it up or down, offset from host it'll move it away or closer to the wall. There are also several other parameters, and when you click Edit Type, you can view the type parameters, and depending on the family that you loaded and placed, these parameters will vary. Next, we will place an electrical transformer outside of the electrical room. So once again, on the Systems ribbon in the electrical panel, we'll click Electrical Equipment, and then we'll expand the type selector. We will select one of the dry type transformers. I'll select one of the larger ones for this example. And when you move the cursor into the drawing area, you can see the equipment attached to the cursor, and there is no placement panel in the contextual ribbon. So this is a non-hosted family. There is a level parameter and an elevation from level, and then there's still a host parameter. So even though this is not a hosted component, it will still have a host parameter. It just does not have to be placed in a host. If you press spacebar, the component will rotate in 90-degree increments. And in this case, we have a pad that is at a 30-degree angle. And so there's obviously several buildings that are at an angle, or there are certain rooms that are at an angle. And when this is the case, you can hover the cursor over an edge, so really over any line, and then press the space bar, and the component will rotate in increments relating to the angle. And so in this case, we'll simply click to place it when we have it rotated appropriately. And then also, if you don't want to do that, or depending on the situation, you may also want to use rotate after placement. So when this option is selected, when you click to place one of the components, then the rotate control will become active. And you can then type in any angle, such as 45 degrees, and press enter, and the component will be rotated, just like you were using the rotate tool. I'll click modify to end the command, and since we don't need this one, I'll actually select it and delete it, and that is how we can place electrical equipment. In this lesson, we will cover recognizing hosted and non-hosted components, placing components at the correct location, and adjusting room calculation points. In this model, there's currently not any lighting fixtures or electrical devices placed. We will place a few lighting fixtures, and then we'll place a few receptacles. Lighting fixtures are typically placed in reflected ceiling plan views. That way you can see the ceiling grid. So I'll open the lighting ground floor RCP view, and as discussed, you can see the ceiling grid in the architectural model. To begin placing lighting fixtures, switch to the Systems ribbon, and then in the electrical panel, click Lighting Fixture. The first thing you want to do when placing lighting fixtures is select the correct type in the type selector. In this case, there's just one family loaded with several types, but in large projects, you could have hundreds of types. And so you can use the search field to narrow that down. And so the nice thing about the search field is that it does not have to be case sensitive, and it does not have to be exact. And just to see what I mean by that, if I type lighting, you can see lighting highlight in the family name. And then if I type a space and then enter 2, all the 2's highlight. And so you'll notice that lighting space 2 does not appear in the same text string in the family name or the type name, but each of those individually is highlighted. So if I'm searching for a lighting 2x4, some type of 2x4 lighting device, those will highlight in either the family name or the type name. Now it is important that the spacing matches though, and let me show you what I mean by that. If I type 2x4 dash, then everything goes away. But if I type 2x4 space dash, then the dashes will highlight. And so the spacing in there matters, and as well as the text strings, but they do not have to be full text strings. It will also work off of partial text strings. So if I type light 2x4, those partial text strings will highlight. So the search field is a quick way to help you narrow down a type that you're looking for. So in this case, we'll use the 2x4-120 type. And in the contextual ribbon, we can see that there is a placement panel. And so this indicates that the light fixture is a face-based component, meaning that it can be placed on a vertical face or a horizontal face. And that could be a floor, a ceiling, using place on face, or you could select place on work plane and then host it to a level or another reference plane. So in this case, we want to place it in the ceiling, so I'll select place on face, and then when I hover over a ceiling, you can see the light fixture, and I can simply click to place it in the ceiling. Now, one important thing to note here is that we are using a face-based light fixture and placing it in a ceiling of a linked architectural model. If we were using a ceiling-based light fixture, in other words, a family that was created using one of the ceiling-hosted family templates, it would not be able to be placed in the ceiling of a linked architectural model. Same thing for a wall-hosted component. So if there was some type of wall-hosted light fixture, it would only be able to be placed on walls in a host model. It could not be placed in a linked model. So just to kind of summarize all that, if you want to host it to a linked architectural model, your lighting fixture families need to be created using a face-based template. All right, I'll click Modify to end the command. Another thing I'll point out is it was relatively easy to snap it to the ceiling grids. If these ceiling grids change in the architectural model, the lighting fixtures will not update accordingly. So if the architect were to adjust these, say a foot, either way, this lighting fixture would not adjust accordingly. It would stay hosted into the ceiling, but it would not move with the ceiling grids. If you had ceilings in the host model and you placed a light fixture, they would adjust accordingly. But I do not recommend placing ceilings in an MEP model unless for whatever reason it was required. But typically those will be placed by the architect, and you can host using a face-based family. All right, the next thing we want to point out here is that the average estimated illumination parameter for the space is starting to fill in. So if I select one of the spaces that where we do not have light fixtures, you can see that it's 0. And in one of the spaces where we do have lighting fixtures, it is starting to populate based on the data from the lighting fixtures. If that was not populating, so let's say you had a light fixture placed, but it was not, the parameter was not populating, then it could be because the lighting fixtures are slightly offset from the ceiling, and so they're not being recognized by the space. And so if there is a gap there, and so a way to handle that is with the room calculation point. And you can enable that by selecting a lighting fixture and clicking Edit Family to open the lighting fixture in the Family Editor. And then in the Properties palette, you can see that there is a room calculation point parameter. When I enable that, then you can see a point appears in the drawing area. And now it's actually above the light fixture, and you can see this yellow symbol right here, and so this is actually the light source. And so the light source and the room calculation point are above the light fixture. And that's just because of the way the family is. That doesn't mean that it was created upside down. That's the way it's supposed to be created, and so that's okay. That's what we want. And so if this was, like I said, the the lighting parameters were not being picked up by the space, you can enable the room calculation point, make sure it's moved a couple foot above the lighting fixture so that when you load it back in, then it will be recognized in the space because this point right here will be in the space. And in our example, it is reading fine, so we will not load that back in. Next, I'll switch back to the power ground floor view, and we'll zoom in to one of these rooms here, and we will place some electrical devices. And so another way that you can place, it could be lighting fixtures, equipment, lighting fixtures, is you can expand the families branch in the project browser, and then you can locate the category of elements. So in this case, we'll expand electrical fixtures, and you can see all of the families that have been loaded into the project for that category. In this case, there's a duplex receptacle, and when I expand that branch, you can see two listings here, GFCI and standard. These are the two types that have been loaded in. And when I drag and drop one of those into the drawing area, the tool is activated. And so just like if I was placing an electrical fixture using the electrical fixture tool from the systems ribbon in the electrical panel, I'll go ahead and do that. And then the standard duplex receptacle is selected. So just another way to activate the tool. Once again, this is a face-based family. We'll do place on vertical face, and I'll click to place a few in the model. And so it's, once again, just hover over a wall and click, and those will be placed. And they will be placed at the scheduled level and the elevation from that level. I'll click modified in the command, and then if needed you can select it afterwards and adjust the level and height as needed, and then you can see that there's a host parameter, and then you can always use this offset from host parameter to move it away from the host object. So in this case the host is a wall, so we can move it away or closer to the wall. Okay. Next, I will click Edit Type, and we'll look at a couple more things here. And so in the Type Properties dialog, you can see a Load Classification parameter, and it is set to Receptacle. And if I click the More button, it's going to open up the Load Classification dialog, and you can see that the demand factor is set to Receptacle for this Load Classification type. And if you click the More button again, then it's going to open up the Demand Factors dialog. And so before you begin creating circuits, it's always good to make sure that your electrical fixtures are assigned to the correct load classification type. In this lesson, we will cover creating and editing circuits and adjusting circuit properties. In this model, lighting fixtures have been placed along with some of the electrical devices. At this point, you can begin creating circuits. You can create circuits for power systems along with some low voltage systems, such as data, telephone, and fire alarm. In this lesson, we'll look specifically at power systems. And the important thing to keep in mind is that only compatible devices can be connected. And that means that they have the same distribution system, which is made up of the voltage definition and the number of poles. We can take a quick look at that if we switch to the Systems ribbon, and in the electrical panel we'll click the dialog box launcher, and then we'll look at the distribution systems settings, and you can see that it's made up of the phase configuration, a number of wires, an LL voltage, and an LG voltage. And those voltage come from the voltage definitions here, and so there is a minimum and maximum voltage, so there's a range here to make up these voltages, and then once again they can be selected here to make up the distribution system. Now when we take a look at the components that can be added to a circuit, the important thing to keep in mind is that they must have an electrical connector. So I'm going to select this receptacle and click Edit Family. And then when I look at the family, I can see the electrical connector here. And when I select it, you can see that there is a system type parameter. And so this one is set to power unbalanced. But as I described earlier, you can create circuits for several other types of systems, such as data, telephone security, so on. And once again, power. Power is the main one we're focusing on. And the important thing to keep in mind with power circuits is the voltage. And so here's a voltage. All of the electrical connectors will have a voltage parameter. And this one in particular is associated to a family parameter, which is the switch voltage. And so that's where the voltage of this receptacle can be controlled. Okay, so once again, to be added to a circuit, it must have an electrical connector, and you need to pay attention to the voltage and the number of poles and the system type for each connector. Okay, we'll close that family and go back to the model, and let's create a circuit for these receptacles. So if I select a receptacle, you can see that in the contextual ribbon there's a Create Systems panel and power is available. And that is due to the electrical connector that we just looked at. When I click power, a circuit is created. And right now that only that single receptacle is added to the circuit. But at this point we can click Edit Circuit and go into Edit Circuit mode. And then there are a couple options here. Add to circuit and remove from circuit. So with Add to circuit selected, I can begin selecting other receptacles or even other, once again, other compatible devices that could be on the circuit. So in this case, I could add lighting fixtures that are 120 volt. I'm simply going to continue selecting receptacles. And in a minute, I'm going to get a warning, and there it is. So now it's telling me that the total connected load for the circuit is exceeding 80% of the defined rating. And so right now the rating for this circuit is set to 20 amps, and I'm exceeding 80% of that capacity. And so Revit's going to warn me of that. So I can select Remove from Circuit, and I'll remove a few of these devices. And so you'll notice that as I'm adding components, as I'm adding these receptacles to the circuit, they're becoming bold, and the ones that are removed, they are now dimmed. And so that will tell me which components have been added to the circuit. Once I have all of the fixtures that I want on this circuit, I can select the panel. There's a drop down, and I can expand that drop down and I can select the panel. Or if I wanted to, if it was visible in the view, which in this case it is, I want to assign it to LP1. I can click Select Panel and then select the panel in the drawing area. Once again, I can select it from the drop down or click Select Panel and then select it. And then once I have that finished, I'll click Finish Editing Circuit, and all of my receptacles that I selected are now added to the circuit. And when I select them, you can see the electrical circuits contextual ribbon, and the ones that I removed, those are obviously no longer on the circuit. Another way to create a circuit is to select those components beforehand. So I'll select a handful of lighting fixtures, and when I do, once again, power is available in the contextual ribbon, and I'll click power, and only the selected devices are added to the circuit. I can select one of the fixtures in the circuit and switch to the electrical circuits contextual ribbon, and I can click Edit Circuit and add additional fixtures if I wanted to. And also be aware that those were added to panel LP1. And that's because panel LP1 was the last panel that I used for a circuit, and so Revit will remember that and continue to add circuits to that panel. And so if you wanted to change that panel, you could do so by expanding that drop down and selecting another panel, and then Revit would use that for the next one. Alright, so we have two circuits created. We added the electrical fixtures and the lighting fixtures to a circuit. Now let's take a look at, we could obviously continue doing that throughout the building. A couple more things I want to cover is we can circuit panels to other panels. So in this case we have panel LP1. In this lesson, we will cover creating and editing switch systems and adjusting switch system properties. In this project, lighting fixtures have been placed along with some lighting devices. In these exam rooms, we have lighting fixtures along with occupancy sensors. These occupancy sensors are lighting devices which can control light fixtures. In order to associate light fixtures to lighting devices or light switches, you can create a switch system. Switch systems are independent of lighting circuits and wiring. When you select a light fixture, there is a Create Systems panel in the contextual ribbon. When you click Power, you can create a power circuit. In order to create a switch system, you can select Switch. When you do, a switch system is created. And currently, just the light fixture that I had selected belongs to that switch system. At this point, you can click Edit Switch System, and Revit goes into Edit Switch System mode. In the contextual ribbon, there is an Add to System and Remove from System tool. With Add to System selected, I can select the other lighting fixture in the room, and then I can click Select Switch and select the occupancy sensor. When I do, you can see in the Switch ID field in the options bar that the lighting switch filled in with the occupancy sensor that I had selected. You can also see the number of fixtures that belong on this switch system. Once you are finished, you can click Finish Editing System. When you hover over a light fixture and press Tab, you can tab until the switch system highlights, and then you can click to select it. When you do, the properties appear in the contextual ribbon, but there's really not many properties that you may use over the course of a project. But you may need to edit the switch system, or you can go back and select a switch or disconnect it from a switch. We'll do one more, and I will select two lighting fixtures and then click Switch, And when I do, the switch system is created, and I can click Select Switch in the contextual ribbon and then click the occupancy sensor. And so that's a quick way to create a switch system without going into Edit Switch System mode. Lastly, one thing to keep in mind when dealing with switch systems is that only one switch can be added to a switch system. So in the case here of the corridor, I have a three-way switch on this wall, and then over here by the nurse station there's also a three-way switch. And so if I will just select a few of these light fixtures and create a switch system, and when I click Select Switch, I can just select one. If I try to click Select Switch again and select the other one, it will simply change to this switch as opposed to this one. And so there's no way to assign two switches to a single switch system. So keep that in mind when you're creating your switch systems. In this lesson, we will cover reviewing systems in the system browser and adjusting settings to review system information. In this project, lighting fixtures and lighting devices have been placed, along with some electrical fixtures. Some circuits have also been created. At this stage of the project, when you're modeling and creating circuits, you can use the system browser to help you keep track of circuits in your model. To open the system browser, switch to the View ribbon. And then in the Windows panel, expand User Interface and select System Browser. By default, this system browser is docked to the right of the screen. You can expand it as needed. To begin, pay attention to the two drop-downs at the top. First, you can choose whether to display Systems, Zones, or Analytical Systems. In this lesson, we're just going to focus on Systems. Next, you can filter the list of systems by discipline. So for this example, we can select Electrical. What's happening in the system browser is that it's tracking all of the electrical connectors in the project. And so you can see an unassigned branch and an electrical branch. Let's start by expanding unassigned and then expand electrical and power. When you do, you can see a long list. And this list is actually all of the electrical connectors that are not assigned to a circuit. And so these are power connectors that are placed on either electrical fixtures or mechanical equipment, and they are not assigned to a circuit. That's why they are in the unassigned branch. When you expand electrical, you can then expand power, and you can see a panel name. When you expand that panel, you can then see circuit numbers, and we'll just keep expanding this and then talk through it a bit. Okay, at this point I've expanded it quite a bit, and I will zoom into the electrical room here so you can see the two panels that we have along with the transformer. And this is how the system browser can also help you see how things are circuited. So if we look at the bottommost level here, panel LP1 is on circuit 1 of transformer T1, and T1 is in 1, 3, and 5 of panel MDP1. And so that's kind of how our circuiting is in this system. And then underneath each panel you can see individual circuits. And as you expand those, then you can see the specific either lighting fixtures or electrical fixtures or whatever may be circuited on that circuit. And so in this case, for panel LP1, circuit 1, we have several lighting fixtures. And as I hover over each one, it'll actually highlight in the model. And now that I'm zoomed out, you can see that in the model as well. There's a button right here which will auto-fit all columns, and so I'm going to click that, and then I'm actually going to collapse this one just a bit That way we can see some of the additional information. So right now, by default, it's showing the space number, the space name, the space number, and then the load and the voltage. So I can see that for each fixture, and then when I go up to the circuit, I can see the total load and voltage of the circuit, and then up again of the panel. And so it's a good way to track circuit information. You'll also notice that when I hover over a circuit, and I can even select it, that circuit will highlight in the model. And if needed, I can right-click a circuit, and there are options such as Select, Show, or Properties. And I click Properties, and the Properties palette will display the instance parameters. And then similarly, I can select a lighting fixture or any device that's on a circuit, and there will be options as well. And so really any listing here, you can select it, and there will be options. Lastly, there is another button over here in the system browser, and it's Column Settings. When I click Column Settings, it opens up the Column Settings dialog, and you can expand some of the branches here and choose additional parameters to show in the system browser. So for example, I'll select number of elements, and then I'll scroll down, and I'll under electrical, I'll select distribution system, and then click OK. And now you can see the distribution system appears. And so one thing I'll point out is that not every option here will be applicable to every system. And so just be aware of that. So obviously there's a lot of parameters here which apply to mechanical or piping systems and not necessarily to electrical. So just be aware of that. If you select something and you don't see it, it's because it doesn't apply to that system. And so I strongly recommend using the system browser. It can help you keep track of the circuits in your model. In this lesson, we will cover modeling conduit and cable trays and adjusting conduit and cable tray types. To model conduit or cable trays, switch to the Systems ribbon. In the electrical panel, you can see a cable tray tool and a conduit tool. Let's start with cable tray. I'll zoom into the corridor, and we'll place a cable tray down the center of the corridor. The first thing you want to do when creating cable trays is select the appropriate type that you want to place. You can expand the type selector and select any of the available types. You can then adjust the size with the width and height controls, and then the middle elevation, which is measured from the reference level, which is in the Properties palette. So you want to make sure you're modeling at the correct elevation. I'll click 2 points to place a cable tray, and then click Modify to end the command, and we'll just have this floating out here in the middle for now. And then I'll activate the conduit tool, and you can see that the options are very similar. Once again, you can expand the type selector and choose the type that you want to place, and then you can control the diameter and the middle elevation. In this case, I'll start in the electrical room, and then I'll come out into the corridor, and we'll route some conduit through the corridor. So essentially you're just clicking to sketch lines, and then the conduit or cable tray will be placed along those lines that you're sketching. One thing I want to point out is that the conduit was created at single line, whereas the cable tray is double line. And that is the default display at the medium level of detail. If I switch to coarse, both of them will be single line, and if I switch to fine, then they'll both be double line. Now you can use another detail level and then override this setting for you can override the detail level for conduit or for cable trays in the visibility graphic overrides dialog if you wanted them to appear differently, such as conduit appearing double line when the view is set to a medium level of detail. Alright, let's create a section, and one important thing to do is to coordinate as you're creating conduit and cable trays. And when I open this up, you can see here my conduit and the cable tray is running directly through the ceiling. But with it selected, I can adjust the middle elevation in the options bar, or if I know the bottom elevation or top elevation that I want, I can adjust either of those in the properties palette. So if I set this to 10 feet, if we want this above the ceiling, then I can control the bottom elevation. And then similarly here, conduit, I can control top, middle, or bottom elevation. So we'll move those up. And then once again, if you wanted to switch to the fine level of detail, that will control how they appear in a section view as well. As far as the options when creating conduit and cable tray, in the options bar you'll notice, in the contextual ribbon, you'll notice several options here. And the justification parameters, that will, since we're modeling conduit, if you are modeling eccentric reducers versus concentric, you could adjust the justification settings in order to model that. It does get a little tricky when you're trying to connect conduit to other conduit if the justifications do not match. Automatically connect, that will, just like it says, automatically connect. So if I simply change I'm going to change it to 10 feet and then we'll do a cross. And when I do, a conduit junction box was automatically added, and that's because automatically connect was selected. If I deselect that and then do the same thing, Revit does not connect those two conduits. So typically you'll model with automatically connect selected. If you want to begin from the end of an existing run, you can use inherit elevation and inherit size, and just like it says, it'll inherit that elevation and size if you do not know what that is at. I will select add vertical, and then if let's say I was dropping down to the ground, I'll change it to 0, and then I click at the end of this run. And what is happening here is that there is a vertical drop that is added, and that's because add vertical was selected. Change slope, it would simply change the slope and it would slope down to the point that I selected. And so that's what these add vertical and change slope options will do. And then lastly, tag on placement. If this is toggled on, then a tag will be placed on the conduit as you create each segment. Place a couple there and you can see a tag is added. And once again, these options are available when creating cable trays, and the only thing is that the add vertical and change slope are not available for cable trays. Now, to wrap up, let's discuss the conduit and cable tray types. So if I select a cable tray and click Edit Type, you can see things like horizontal bend and vertical inside bend and outside bend and T and cross. And so these will control the fittings that are used when you are routing cable trays. And then similarly for conduit, these types, the fitting types are controlled in the cable tray type. And for each one there are two system families. So for conduit, there's conduit with fittings and conduit without fittings. I will click OK. And one more thing that I'll show here as we wrap up. So I'll activate the conduit tool, and if I route at an elevation of 10 feet, and then we'll have add vertical selected, and I change it to 11, and you can see that when I move my cursor that there is a cannot place symbol. And so when you get something like this, that means that there's not enough room for that fitting to be placed appropriately. Or in some cases, if it was too small, you may not ever get that option to get it to place correctly. But in this case we did. We had enough room. 6 inches was enough to place our fittings there. But when you have that cannot place option like we have right here, that means there's not enough room for those fittings to be placed. In this lesson, we will cover adding wires to circuits and adjusting wire parameters. In this project, some circuits have been created and we can now add wire to those circuits. This can be done automatically or manually, and we'll take a look at both options. On the Systems ribbon, in the electrical panel, there's a wire tool. You can expand this split button and see that there are 3 wire tools: arc wire, spline wire, and chamfered wire. I'll select arc wire, and then I'll zoom into one of these exam rooms, and I will click the receptacle and then a midpoint between these 2 receptacles and then this other one, and I can place a wire between those 2 receptacles. And then I'll click Modify to end the command. That's how you can manually create a wire, simply just by clicking points, or you can automatically place wires. And we can do that by selecting, or actually we'll hover over a component that is on a circuit, press Tab to highlight the circuit, and then click to select it. When you do, you can see 2 icons in the drawing area, one for arc wire and one for chamfered wire. And there are actually 2 tools in the contextual ribbon that match these icons. You can click either arc wire or chamfered wire. So I'll select arc wire, and when I do, arc wire is placed between all the components on the circuit. So you can see that's a much quicker way of placing wires. And afterwards, whether you manually create it or automatically create it, you can select those wires and adjust them as needed. And so once again, 2 ways to either to create wire: either manually do it or automatically create those wires. A couple notes about wires. So wires is a model category, and I can see that if I go to the Visibility Graphic Overrides dialog, I can see wires, but it behaves like a view-specific element. So these will not appear in other floor plan views, and we can see that if we duplicate this view, we can take a look to see those wires are not here, whereas things like conduit and cable tray would be. So just be aware of that when working with wires. Also, when you select a wire, you can adjust certain parameters, such as the tick marks. You can even adjust the type, whether it is an arc wire or a chamfered wire. You can switch between those if needed. But in this case, really, to be honest, if you want to switch from arc to chamfered, you should just delete the wires and then automatically create them again as chamfered wires. You can control the number of hot, neutral, and ground conductors. And then, so those are the instance properties available. You'll notice that wire size, that cannot be adjusted. And so that is calculated by Revit. You can also create different wire types as needed. And then if you click Edit Type, you can see the type properties. And the type properties, that's where you can control things like the material and the temperature rating, insulation, and the other parameters you see here. I'll click OK to close this dialog. And one thing that is troubling to some Revit users is that they cannot adjust the wire size. As in this case, as we just saw, the wire size parameter is grayed out and cannot be adjusted. And so one of the ways that you can adjust the wire size is by adjusting the circuit path. And we can take a look at that. If I select one of these light fixtures that are on the circuit, I'll switch to the Electrical Circuits contextual ribbon, and you can see that there's an Edit Path tool. And I'll click Edit Path. And when I do, I can see the path from the farthest device on the circuit to the panel. And in the contextual ribbon, I can see the length of this circuit path, and then I can adjust the path mode and then the path offset. So before I do that, let me scroll down a bit in the Properties palette so that we can see the voltage drop, which plays a big part in Revit's calculating of the wire sizes. And then you can also see the wire sizes for this circuit. And so if I change from farthest device to all devices, you can see the voltage drop changes. In this case, the wire size does not change. But if I change it back to farthest device, you can see the voltage drop change again. And this time I'll adjust the path offset, and the voltage drop changes, but the wire sizes don't. But just so we can kind of see that, if I select the path, and so in addition to modifying those parameters, you can actually move the path lines as well. And if I drag this, we'll just drag it all the way down for sake of example, you can see that those wire sizes update accordingly. And so obviously the length here is quite a bit longer, and so that's why those wire sizes are adjusting. And as I move it back, you can see that those wire sizes will change accordingly, because as Revit is calculating the length and the voltage drop, those are all being taken into account to calculate those wire sizes. So just to summarize, if you want to adjust the wire sizes, it's not something you can do by adjusting a parameter, but you can edit the circuit path in order to adjust that. I'll click Finish Editing Path. So just to summarize, you can create wires manually using one of the wire tools, or you can create them automatically by hovering over an item on a circuit tab, select, and then clicking either arc wire or chamfered wire.